Okay, so Olivia, you asked me to do this question, so Alyssa, I'll share this with you as well. How to take the integral of cotangent to the fourth. These problems are very challenging because there's just a bunch of weird trigonometric substitutions that happen. So I did kind of figure it out, but I got to admit it was not an easy thing for me to do either. So let's go ahead and run through the process. So I know that your background in trigonometry sometimes is a little bit less than some. So let me take you through the beginning. First, you want to be aware that there's a nice trigonometric identity, which we call the Pythagorean identity, that the sine squared plus cosine squared is 1. Now, we also have some extra little side pieces that the sine over the cosine is the tangent. And in a similar way, cosine over the sine is the cotangent. And we have two more to deal with it. 1 over the sine is called the cosecant, and 1 over the cosine is called the secant. Now again, in other countries, they may call them slightly different values, but that's kind of how we refer to them here. So by utilizing these in the following effect, I'm going to divide all of these through by sine squared. Now, not everybody does it this way, but this is just kind of how I do it. And that would give me 1 plus the cotangent squared of theta is equal to the cosecant squared of theta, also known as that the cotangent squared of theta is cosecant squared of theta minus 1. So within here are some fairly significant little details. This little gem right here, I'm going to use a lot. I'm going to go ahead and use that a fair bit in this little story coming up. So when we looked at the integral of the cotangent to the fourth of x dx, the first thing is we're going to go ahead and split this up as the cotangent squared times the cotangent squared. So I've got cotangent squared times another cotangent squared, but instead of calling it cotangent squared, I'm going to call it cosecant squared minus 1. So for the next little piece of the puzzle here, I'm going to go ahead and break this thing up a little bit. And I'm going to rewrite that then as the cotangent squared of x times the cosecant squared of x minus the cotangent squared of x dx. Now, before I go too much further, I do want to remind you of something, is that with the basic stuff of derivatives, we should know that if you took the derivative of the cotangent of x, we should get the opposite cosecant squared of x. In other words, if you took the derivative of, this is just sort of how that happens. So if you wanted to write it this way, this is kind of a strange way, but if you said u was the cotangent of x, then du would be negative cosecant squared of x dx. Now that's actually going to be a very, very helpful thing for us in context of this problem in a few moments. So when we go a little bit further, it looks kind of strange because I did this substitution once, but I'm going to do it one more time. So I'm going to set this up pretty thoroughly. So I've got cotangent squared x times the cosecant squared of x. And I'm going to replace this negative cotangent squared of x with this thing right here. So keep in mind it's a negative, and so that's going to lead me with a negative cosecant squared and a positive 1. And all of this stuff is, of course, dx. Now, here we go. We're going to get this thing going here. So if I were to let u be the cotangent of x, like I did up here, then du is, of course, negative cosecant squared x dx. And so when we look at this front part of this equation, I'm going to go ahead and use this highlighter. If we look at that front part of that equation, what I really have is opposite u squared du. Because if you see this cosecant squared, that's negative du, and that is u squared. Now, as I carry on through this problem, I'm going to go ahead and do the following. I'm going to keep breaking this up. I'm not going to use the u substitution on the backside because those are actually fairly well defined. So we have negative 1/3 u cubed off of this side. We already have established that the integral of the cosecant squared was the negative cotangent. That was something that we actually saw up here in that original stuff. That was the negative cotangent of x. The integral of 1, of course, is x. And of course, then we have the last little thing that's just plus c because it's not a definite integral. And then the only thing left to do is to substitute back in because we decided u was cotangent of x. So we've got negative 1/3 cotangent cubed of x, cotangent of x plus x, and a plus c. Now, the only thing I didn't really thoroughly land the plane on was right here, but you can see if I integrated this, because notice I took the derivative to go down, so if I integrated, I could come back up, and that's how that actually plays out. So anyway, that kind of establishes what we had in that question, and I hope that is helpful. And so let me know if you need anything else. All right, bye-bye.